This is our special speaker for today, Simon Martinelli. That's his Twitter handle. He's the owner of 72 Services LLC, which is a Swiss-based IT consulting firm. He's a recognized software architect, lead developer, consultant, and trainer for 27 years, focusing on enterprise Java. He's also an international speaker, the recipient of the Vaden Community Award. He's interested in increasing the efficiency of full-stack development with Java, and he's also a regular contributor to many tech articles. Also a lecturer for software architecture and persistence, and this is his blog site, if you're interested in it. So I'll be sharing this slide deck with you. And without further ado, we have you join us now. Simon, thank you.
Thank you, Mary, for the introduction.
Yeah, thank you.
Let me share the screen. Oh, I'm amazed to be speaking at the Java User Group in Chicago. Unfortunately, I cannot be there, but maybe it will be in the future. Mary introduced me a bit, so just a few words about myself. I'm also organizing Java User Group in Switzerland. We have 5 cities in Switzerland, and we are a Java User Group. I'm organizing events in Bern. I'm doing software development for close to 30 years, and I'm also teaching, as Mary already said in the introduction. But today I'd like to talk to you about something completely different, and this is track and field. Beside my work, I'm in a sports club in Switzerland. I'm doing track and field already for like 40 years. And in the sports clubs, we also have a small competition for kids. And close to 25 years from now, I started to write software to manage the competitions. And finally, this resulted in a software called JTAF Track and Field. It's an open source application, and it's like my pet project that I usually use for trying out new technologies. Currently, JTAF is made with Vaden, as you may already heard from Mary, which is my favorite front-end framework, and jOOQ that I will introduce today in my talk. I also took the data model out of this track and field competition software, and this looks like that. So, but before we look at the data model, let's have a short look at the application. That is how the application looks like. So we have all data here. Let's go to the production version of that, and we can see that we have also competitions that are upcoming. So the next one will be at August the 26th, and we had some like a few weeks ago. This application here is a typical business application. So if you're also building enterprise level business applications or applications for smaller companies or software like ERP systems or something like that, you may also do similar applications. So what we can do here in the application, we have a dashboard. So on the dashboard, for example, we can have a look at the ranking lists. And the ranking list here, for example, shows the competition. We have categories with the age of the kids here, and we have then the participants, and below the participant we also see the event. So 80 meter, for example, that's long jump, shot put, and a 600 meter run. And we see also the results and the calculated points, and this will form this result list. To create this ranking list, we need some master data. First of all, we need the participants or the athletes. So we see here a grid with all the participants. We can, for example, also filter, and finally we also can edit the data. So that's how a typical business application look like. You can enter data. So there is very little business logic. The only business logic that we have here is when we enter results. So for example, if we go ahead and enter some data, so we can change here, for example, the time in the 80 meters and say that was 12 15, for example, and then here on the right-hand side, you can see that the points are calculated based on a formula from the International Track and Field Association. So that's the business logic, but all the rest that we have here in the application is more or less create, read, and update of data. So why do I show you this application? That's because we usually need some persistence layers. So in my case, this data is stored in a Postgres database, and the question now is, how do we access the data? This is the data model. We have kind of an organization on top, so that means the application can also be used by many organizations. We have then the athletes. The athlete can be in a club. We have series and competitions. Why do we have series? Because we have like competitions that are multiple times a year, and finally at the end of the year there will be a ranking list for all these competitions. That's why we have like an intermediate step between organization and competition. And finally we have the athlete that is in a category, and then he will have some results for the events, and this will be calculated, the points, and we will have the ranking list finally. So now if we think about persistence with Java, we usually come to Java Persistence API. Java Persistence API is the standard API for persistence with Java, and there are multiple implementations. The most famous implementation for sure is Hibernate, but there is also Eclipse Link. Eclipse Link is formerly known as TopLink. We have Data Nucleus, OpenJPA, and some others. And on the other hand, we have a framework called jOOQ, jOOQ. And so the question is if they are really competitors, or how do they compare? The point is there are two approaches. One approach could be the JPA approach. That means we have entities, entities have state, and state will, we have state transition during the life cycle of the entity, and then the framework like Hibernate will do updates, inserts, and deletes based on this entity state transitions. So we don't care about the database really. We just use the database as a persistence layer, and on top we work with our class model and also navigate to the classes and so on. On the other hand, we have something called dataset transformation. Dataset transformation is SQL. So we load a dataset, or we load a table, so the result of a SQL statement is usually a table, and then we change the data with insert, update, or delete statements. The point here, and that's very important, neither of these approaches is the best. So it really depends what use case you have. In my use case, with the Java Track and Field application, the dataset transformation is the easier one, because as you've seen during the short demo of the application, usually I display datasets or records, and then I can change the records. The records will be stored in the database, and there is not a lot of business logic that must be on the entities. And I also don't have any business logic that is really doing entity state transition, and I don't have a benefit of using like a norm mapping framework instead of SQL statements directly. So the question is, what is jOOQ? That's from the website of jOOQ. You will find it on jOOQ.org. And jOOQ generates Java code from the database and lets you build type-safe SQL queries through its Fluent API. What does this mean? First, there is an example project, by the way. It's on GitHub. simas.ch is my GitHub account, and the project name is jOOQ Examples. You also find the official documentation, and jOOQ has also a demo page where you will find a lot more examples if you're interested in such a demo. The difference between jOOQ and Hibernate or JPA is jOOQ assumes that there is a database. So if you're using JPA with Hibernate, you can choose how this should work. So for example, you could let Hibernate generate the database tables, or you could have an existing database and map the database to your object model. In case of jOOQ, jOOQ always generates classes from an existing database. The other difference is if you're using Hibernate and, for example, you're using inheritance with Hibernate, there are different strategies how you can map inheritance to a database tables. So Hibernate has an opinion how your database tables must look like, that it could be mapped to the database, to the entity model. But with jOOQ, it really doesn't matter. So every database, also legacy databases with generated primary keys, for example, or composite primary keys, it really doesn't matter. jOOQ doesn't care at all about your database structure. Now, how does it work? jOOQ has two parts. So the first thing that you need is a generator. So you will have a database. We will see that in the demo that there are various ways how you can access the database or the database schema to generate the code. Then the generator will generate Java classes. And finally, you will have a jOOQ domain-specific language that you can use to execute SQL statements. The jOOQ DSL is more or less like SQL embedded in Java. So if you know SQL, then you also know jOOQ, and that's very easy to work with. One question that I had in the last time when I gave that talk is, does jOOQ scale? Because, you know, my pet project, the track and field project, is a very small project. We have a handful of tables. But the point is, jOOQ even comes from a much bigger software requirements. So initially, Lukas Eder is the creator of jOOQ, by the way. He's also from Switzerland. And he was working for a Swiss bank, and he had to access a huge database with thousands of tables for use and store procedures. And the queries were very, very complex. And so he was looking for something how to use that from Java. And then JPA or Hibernate was not really an option. And that was the starting point for jOOQ. So he decided to create a framework that can access a lot of database tables and do complex database queries. My largest custom project where I use jOOQ is an ERP product for a company in Switzerland, and we have around 2,000 table and views, and the business logic is in fact in the database because the ERP system is already 30 years old, and it's based on an Oracle database, and they decided years ago to have business logic also in the database. So that's why we have stored procedures, and stored procedures or accessing stored procedures with jOOQ is also very easy. I will not show that today because I don't have any stored procedures in my demo projects, but using stored procedures with jOOQ feels like using regular Java classes. That means jOOQ generates a Java class for each stored procedure and each function, and you can instantiate the class and execute it, and this will execute stored procedures behind the scene. So it just feels like regular Java code. So that's more or less everything that I have to say about the introduction. So let's have a look at some code. That's my jOOQ example. It's a regular Spring Boot project. It really doesn't matter what framework you're using to run your application. So I just use Spring Boot because I'm used to use Spring Boot. That's my main framework I use for development. But you could also use Quarkus, or you could even use jOOQ without any framework. So jOOQ is not bound to any framework. But for example, with Spring Boot or with Quarkus, you have some convenience if you integrate jOOQ with one of these frameworks. We will see that in a minute. So this is Spring Boot project. We also have Spring Boot started jOOQ dependency here that will integrate jOOQ, for example, with transaction management of Spring Boot. I use Flyway. Usually newer projects at least are using migration scripts to do database migrations. There are two open source projects. One is Flyway and the other one is Lickybase. I use Flyway because it's easier. I just have to add some SQL statements. But I also use Lickybase in other projects. For example, if we have to build an application that is a bit independent of the database, so we should be able to create database schemas for example, SQL Server and also Postgres, then you could use Lickybase with an XML-based migration that will be database agnostic. Then, just for the demo purpose, I use H2. By the way, I no longer use H2 in real-world projects. I don't know if you know the framework. It's called test containers. It was created recently, and the idea is that you run your tests against Docker containers, so you don't need really an in-memory database anymore. You just run your tests against test container database. And we will see that also because in my track and field project I use test containers as well. So that's it from the dependencies. Now the interesting part is under the plugin section. By the way, I show you Maven. That's why I prefer Maven over Gradle, but that's my personal preference. You could also use Gradle. There is also a Gradle plugin to generate the jOOQ code. I just show you Maven because it's even easier to explain. It's a bit more verbose because of the XML, but the structure is easier to understand than with Gradle. So what we have here is this jOOQ CodeGen Maven plugin, and there we can define first when should it be executed. So it will be executed when the sources are generated, and then we can do some configuration. We can configure a lot. There is a huge section in the jOOQ documentation about all the properties that you can set for the generator. Here we have a very simple setup. The first thing that I have to define is where's my database. So in this case, and this is also just for demo purposes, I use DDL database. A DDL database means I don't have a really database to generate the code from. I just have the SQL scripts to create the database. So if you look at the scripts here on the resource DB migration, we have a SQL statement to create database tables. So we have the athlete, category, the club, the competition, and so on. And jOOQ in that case will take the SQL statement and generate code from the SQL statement. That's why I have to define where the scripts are. And what I also additionally do, I define how the SQL script should be sorted. In that case, I say it's sorted in the Flyway way. Flyway uses like this V and then a number before a double underscore, so it will be sorted as Flyway would sort it. And finally, I can define where to put the source code that will be generated. In my case, I put it in that package here. And so if I run my Maven build, we can see here that the jOOQ CodeGen Maven plugin will start. It analyzes the DDL scripts. Here we see also all generator parameters that we could set. We could also generate JPA code. We could generate bean validation. We could generate a lot of stuff. We could even generate data access objects, or kind of repository style classes, and so on. There is a lot of things to configure. And finally, jOOQ found 14 database tables. And from these 14 database tables, he is creating the tables. So here, for example, he has found a table called athlete, and it has a primary key, and then it generates an athlete table. So let's have a look at this generated code. This can be found in the default location, so that's generated sources in the Maven target directory. And then we have a jOOQ folder, and here we have our package, so the database package with some information about the tables, about the catalog. But the interesting code is in the tables package. And here we see that we have a class per database table. So first we have this athlete database table. And here we see that this extends from some jOOQ base class, and it has constants. Why does it have constants? These constants can later be used in the DSL to generate or to create the type-safe SQL statements. That's the idea of these constants. Then we see that we get also constants for each column. And this is very interesting because jOOQ generates not only this constant, but he also defines the type. So in that case, it's a long in the Java type. But we also see here that we have an SQL data type. So in the database, in fact, this is a big int. We also see that this field is nullable false. So this means this is a mandatory field. And we also have a default value because default value is the next value from a sequence that I'm using. And finally, we could also see a comment here. I don't have any comments on my database column, but you can also generate or add comments to database tables or columns or constraints or any other database object. And this will be also integrated in the generated code by jOOQ. So you could document your database model in the database, and then jOOQ will also use that. And this would be very helpful for someone who has to write the business code. He can immediately see what the purpose of the column could be. So that's for the fields or for the columns. And what we see down here as well is we also see some, where do we have it? It's too fast. We also see the primary key. So that means that we also know which field will be the primary key, for example. And we have also references. So, for example, the athlete has a reference to a table called Athlete Club and a table called Athlete Organization, and this is all integrated. Usually you don't need that. So that's for jOOQ to generate the SQL statements, but sometimes this is very handy. For example, the ERP product I was talking about, there we have some generated UIs. So we generate UIs based on the database model with some additional metadata. And there I inspect also or use the generated jOOQ classes to build the UI. So this is could be very helpful to get some metadata about the database tables. What we also get additionally is we get records. So for every table, jOOQ is also generating a record. The record is the result from a query. So if you do a select star in terms of SQL, then you will get all the columns back from the database, and this will be able to map to this athlete record. The athlete record, by the way, extends if the table has a primary key, the updatable record impl, and the updatable record impl gives you kind of an active record pattern. So that means we have here, for example, like methods like store that will do an insert or an update, or we also have a delete, or we have other methods that we can use there. So that's what jOOQ generator does. Now let's have a look how this works if you want to write SQL statements. There is a class in the demo project, it's called query test. Query test is using Spring Boot test slices. Don't know if you're using Spring Boot, but for those of you that use Spring Boot test brings a concept that's called test slices. Test slice means that for a particular test like this jOOQ test, Spring Boot will only spin up the necessary parts of the application. So in that case, if you use jOOQ test, you will only have the database connection, and that's it. And we also have this DSL context. That's the DSL base class that we use to create the statement. So you'll see that in a minute. And that's all here that Spring Boot will create. So that's beneficial because it doesn't start all the other code that maybe is not necessary just to do the database tests. So let's have a look at the first simple query. Here we have a query that selects all records from the competition table. This select from, by the way, is just a shortcut for select from, like that. And because here we don't define which columns that we want to get back, so select from is the simpler form. And here we see that we use this constant. So competition in that case is the table name and is from the generated competition class. So if we change the competition class, for example, then our code will no longer compile. So that's the big difference between using jOOQ for SQL statements than using SQL statements as a string. So for example, with the newest version or the newer version of Java, this became even better. So you can have now multi-line strings, and I could write the same statement here, for example, like this. But the point is, this is just a string. So no one will help you. So if you rename the competition table, you would need, first of all, tests of all your queries that you find out that maybe the test no longer worked because something has changed or was renamed, or you have to find replace and replace that all over your code. With jOOQ, you don't have to do that. jOOQ will just not compile, or the code will no longer compile if the names do no longer match. That's one of the benefits. We also see that we define the query, then we have a fetch method. Fetch means this executes the query. There are different methods that you can have here. We also have like stream, then you get back a stream. Here with fetch, you get back a result. Result is a class from jOOQ. It implements lists, so you could also exchange that to list because result also implements list. But there's no change about that. Now that's the simplest way how to find something. Let's see how we can insert data. Insert data can be done with an insert statement. So no surprise, if you know SQL and the insert statement, you see that we can insert into a table, and here we use the columns of the table. Also here, that's the generated code. It will be type safe, and we add some values. So for example, we add here Sanai Richard Ross. That's a US runner. He's one of the fastest women in the 80s. And what we can do here as well, for example, we can return some ID from the insert statement. So SQL, it depends a bit on the dialect or on the database that you're using, can also return something. So in that case, we want to get back the athlete ID. Why do we want to get it back? Because we have a default value on the primary key that is taking the ID from a Postgres sequence or from a sequence, and that's why I want to return that here. And here we see that this fetch is also in a different flavor. We have a fetch one, that means fetch returns a list or a result. Fetch one returns exactly one result. That's similar to the entity manager with JPA with get result list or get single result. Here we have fetch and fetch one. And into means I can tell jOOQ that it should return the element not as a result or a record. It should return it directly into another type. So in that case, along. And this fetch into, jOOQ will try to find the constructor or any other mechanism to create an instance of that. Now this looks a bit not so nice, I would say. So I don't like really writing insert statements my own. And you don't have to do that because we have the record. So we have this athlete record, for example. And on the DSL class, we have a method called new record. We can pass the table and then it will create a new record. Why do we need this one? Because we could also write that with just calling the constructor. So this one would be the same, but the difference here is the athlete record after instantiation is not managed by jOOQ. That means later on, so we set here the fields, we have first name, last name, and we set it to Muchinga Kumponchi. She's the fastest woman in Switzerland currently, and then we store it. But store only works if it's managed, so we have the same ID as we also have with Hibernate. There we have entity states. Here we have kind of record states, so it must be the managed state or in the attached state, it's called in jOOQ, that it can store it. So this one will create the same thing. So let's have a look, by the way, what it does. So if I run the test, jOOQ will also display some information about the query. I can enable jOOQ logging. There's a logger called org.jOOQ, and I can set it to debug level, and then it will run. And it's quite interesting what it will print. It will print the SQL statement. So for example here, because we have a returning, we have to do a select ID from the insert statement here. That's a bit special because it's H2. In other dialects it would look different, but in fact we have the insert statement here with the athlete. And we see here the question marks. That means jOOQ generates prepared statements. So you don't have to care about SQL injection. jOOQ is safe against SQL injection because it will always create a prepared statement. So there's no way for SQL injection in that way. But the problem is if you want to debug the code or if you want to look at the code, then it's a bit difficult to find out what exactly is in this prepared statement, and so jOOQ always will also create a debug statement with the inlined values of the parameters. That's very handy, as you can see here. And finally, jOOQ also creates a sample of the result. So for example, if we run the first select here on top, then we see that it will sample some of the data. It will not display all the records because you may have a table with thousands or millions of records. It will only sample 5 as soon as I know, as far as I know. And here we see that it returns it in a table that is easily visible for testing. So that's inserting. But often we don't want to fetch all the data from a table, or we want to do a join, for example. And this can be done for sure as well. We can do projection. That means we can select only like a few of the columns. For example, we can select the first name and the last name of the athlete and the club name. And then we do a join on the club table. Here, because we don't map any relationships, so we don't map like an athlete has a club, like we would do with JPA. So because this information is not there, we have to do a join. And finally, we use fetch into in a different manner. We say we want to get an athlete DTO. And the athlete DTO in that case is a Java record. And Java records is a great thing because it's a perfect fit for projection. So if you have read-only data, then it's the best to use a record because records are immutable. And it's also a perfect fit because each record has one constructor with all the parameters, and this perfectly fits with jOOQ. By the way, this is also type safe, and you cannot do a projection in something that does not fit the record. So if you have the club name here, you will get a failure if you use an integer like in the club name here, in the athlete ID. Exactly. So now it's a bit a lot of work to write all these join statements, but also there is a solution from jOOQ. It's called implicit join. Because jOOQ analyzes your meta model of the database, jOOQ also knows how the tables are related. And so that means that if you have a to-one relationship like we have here, jOOQ will create a method. In that case, it's club. And club is just a navigation with the foreign key to the other table. And so we can do an implicit join and we don't have to write the join here. So these two statements are exactly the same. This one just omit the join because it's not needed, as jOOQ already knows how athlete and club are related. And finally, we have a delete statement here. And delete is as expected. So we have delete from and we define a where statement, and we have here an execute method. So execute means that we will get back the number of affected rows, here in that case, which rows were deleted. So that's how jOOQ works. And you can imagine you can create a lot of complex queries, and you can also use parts of the query. So for example, if you want to store that part of the query, you can do that. So we can use that select part, for example. Let's call it projection. And here we see that this is a select step, for example. And now we can reuse the projection. So we can have the projection here or in any other statement. So that makes jOOQ perfect for dynamic statements, because you can pass around the parts of your query, or if you have like a search form and then you want to create a dynamic query based on the search the user wants to do, then it's very easy to do that in jOOQ. And as I already said, every query is a prepared statement. So even in that case, you don't get SQL injection. So that's safe for this use case. So that's a simple one. Now, the interesting thing about my application is this ranking list. Because this ranking list is a tree. So on top of the tree or the root element, we have the competition. That's here called Wettkampf, is German, it means competition, and Rangliste means ranking list. So that's the top element here. The first, Zist one, that's the competition name. And on the right-hand side, we have the date when this competition took place. And then we have categories. So A, and then we have the boys from year 2000 to 2007, for 2008 and 9, and so on. And later on, we also have the girls. And below the girls, or the categories, we have the participants with the results and the points. So what I would like to do is something like that. So let's go to my track and field application. And here we also have records, but in this case, we have nested records. So we have something called the competition ranking data. This ranking data I use for creating the PDF file. And here, that's the root element. That means I have the competition name, the date, and we have some information about the medals, how they should be calculated. And finally, I have a list of categories. Then I have an inner record category with an abbreviation, a name, year from to, and then the athletes. And the athlete has first name and last name, the year of birth, the club, and the results. And finally, I have the result with an abbreviation, a result, and the points. So this record structure here is exactly the data that I need to create the ranking list. Now the question is, how can I create this data? And here, jOOQ has something called multi-select. Multi-select is something that enhances the SQL in a way that you could return nested structures. Let's have a look at the query. The query is a bit more complex than what we had before. And here we see that we have a select. So that's the most outer query with the name, the competition date, and the configuration. And then here we have the multi-select. And nested in the multi-set, we have another select for the category. Then we have another multi-set for the athlete. And then we have another multi-set for the result. And finally, the multi-set must be converted in something. So we have a convert from method. And here in this method, in this lambda, we get every record and we can map that to the constructor of the result, the athlete, and the category. And finally, we fetch one with a mapping into the competition ranking data. Now, this looks quite interesting. The question is, what happens now? Because SQL, as of today, does not know about this multiset. There are discussions in the SQL standardization groups, and there are also some databases that support kind of multiset construct in SQLs, because usually a database can only return tables. So in that case, it could return nested structures. But the question is, how does jOOQ do that? And jOOQ can do that with like usage of a different feature of most databases. So if we go here back to the list, and then I clean the console, and then let's click on the competition ranking list. This will be created, and here we see the query, or we don't see it because it's here. And the interesting thing about that is the result. So we have a table as a result with the root element. So we have the competition here, but in the multi-set table, there is something completely different. And what we have here is the result of a JSON statement. jOOQ generates out of the multi-set keyword, it generates JSON functionality. So here we have the JSON-B aggregate function with the JSON-B array, and we also have other JSON aggregates for the inner elements and so on. So that means the result of this query will be exactly the data that we have in our nested structure. That's something that you cannot do with any other solution. So you can't do that with Hibernate, because with Hibernate you would get a Cartesian product of it. If you do like a fetch join, for example, you will have multiple competitions, multiple times the same category, the same athlete, and also the other data. So that's really a superpower of jOOQ. I use that a lot, not only here for the competition ranking, but let's imagine you have like a REST API where you want to send out data, also very often also nested data. You can use that functionality. It's perfectly type safe because of jOOQ, and you can use records that are also type safe, that are directly converted into JSON or XML, depending what you're returning from your REST API, and you can use that on the client. The last thing that I want to show you in the demo is the generation of the jOOQ data or the jOOQ classes. That's a bit different because here I use Postgres. I also have scripts. So here we also have DB migration scripts with that's the exactly same SQL statement that we have in the demo project. But here in that case, I use something that's brand new. Test Containers created the jOOQ code gen Maven plugin, and this integrates test containers with Flyway or Liquibase and jOOQ. So what we have to do here is we just have to set what database we want to use. So in that case, I use Postgres, the newest version 15.2. I can set username, password, and database name. I don't have to. This will be handled by test containers behind the scenes. Because I'm using Flyway, I have to define where are the migration scripts. And with the jOOQ converter, I just have to tell where it should generate the classes. And if I execute that, you can see in the output that it will first start the test container. So here we have a Docker container that is starting. It's very fast because Postgres starts in a few milliseconds. Then it generates the classes, and that's already it. So it's very fast, so you don't have to care about that. Now, what's the difference between generating from DDL statements and generating from a real database? The point is that if you're using the DDL database for generating the jOOQ classes, then you are very limited. So not all the features of a database are supported because jOOQ also knows all the database types, and it can generate the data from all the different database objects, for example, store procedures or functions. This will not work, for example, if you're using DDL scripts to generate that. So it's not recommended to use this DDL other than for just demo purposes. So you are much better if you're using brand new test containers integration script, or for example, in the large ERP product, we have a reference database, and we use this reference database to generate the tables because there are so many database objects. We are generating close to 10,000 Java classes, and compiling these Java classes takes very long. So we don't want to have that in the project of the application. We do that in a continuous integration job separately from the application. So that's from the demo. Now the question is jOOQ and JPA, which one to use, or could we use both? The point is the superpower of jOOQ is dynamic SQL building. So it's very easy. You get prepared statements. You're safe from SQL injection. Querying is very easy because you're creating SQL statements with Java. You don't have to deal with strings. Reading nested objects is a unique feature of jOOQ. That's great. And if you really have stored procedures or functions, so for example, if you have a legacy database or someone has decided to use stored procedures as the code for your business logic, then you're super safe with jOOQ. It's very easy to use it. And if you do bulk updates and deletes, for sure, it's even better to use SQL statement, even with JPA. But JPA has also some superpowers. So this so-called entity state transition. So if you have really like object graphs or object trees that you want to use in your business logic, and you want to have business logic on that state, and you want to change it, you want to have like orphan removal, you want to have cascading on insert, update, and delete operations, then I would really go with JPA, because then you're fine, and this really works very well. And that's the point. You can use both in the same project. So what I do in one project, we use JPA to store data, and we use jOOQ to fetch data. So if we read-only data, we always use jOOQ with the DSL and the projection with this nested object functionality. And if we want to store the data, or we read data that we want to change, we use JPA. So it's very easy to combine both. That's not a problem at all to do. So that's it. Thank you very much. Do you have any questions?
Yeah. Yeah, folks, any questions for Simon? No? Quiet? Everybody's quiet today.
I can ask. Sorry, I can ask. Yeah, Mary. Quick few questions about the jOOQ. So my understanding from your presentation that this is jOOQ better suite when we have to use and to be close to SQL database, right? Rather than to object-oriented model, database model.
Yes. So if you really think that your database is the source of truth, then it works perfect. So usually you will have, for example, a consistent data model with not null constraints, even check constraints, for example, then jOOQ is a very good fit. So this means in that case, you will start with the database model. So you usually don't create like an object model or a class model that you later on map to a database. You start with designing the database. So for example, if you have data-centric applications like an ERP system, as I told you, we have 2000 database tables. The database tables are the important part of the application. For sure, there is a lot of business logic on top, but the database is very important for them, so they want to keep the database consistent, and then you can just use SQL with jOOQ. That works very well. Yeah, that's
okay. One more question about caching. Let's say our GPA implementation provides different level of caching. I'm just referencing to Hibernate. Does jOOQ have any kind of caching mechanisms? No.
No, the point is no, because jOOQ has no state. So in contrast to Hibernate, where you have the persistence context or the session plus maybe a second level cache that does not exist in jOOQ. But this is even not very important at all, because even if I use JPA, I don't use the JPA second level cache. What I usually do, I use caching based on the level of the repository. So even with jOOQ, I would create repositories. So I would not spread map. I do that, by the way, in my track and field pet project. Their SQL statements are spread around the application because I just use that. But in a bigger application or in a more sophisticated application, I would use a kind of repository layer, and then you can do caching on the repository layer. So if you use Spring Boot, for example, you can use cache annotations, and then you have the cache on that layer and not on the persistent layer.
Oh, okay. I got it. Yeah. Okay. Thank you so much. Thank you.
Thank you. Anyone else have questions for Simon?
I think I have one.
Yeah. Tom, yes. Hi, Tom.
Hi, Tom.
Hi, Simon.
Hello.
Yeah,
Hi, Mary.
congrats again to Tom for being the latest Java champions.
Yeah. It's another important. So
Yes.
I have an important question for Simon, because I know that I've been struggling with. How do you start to convince the team that JPA is not the only thing in the world?
That's very easy. Wait a minute.
Okay, let's go. It's not Simon disappearing, I hope.
He's running away.
I had to switch on light because it's already dark here.
Oh.
Okay.
Kind of dark.
I thought you were running away from the question, Simon.
No.
I'm glad you're back.
In my case, it's very easy because, I'm teaching at the university, as already Mary said, and I'm teaching JPA and Hibernate for 16 years now. And I also working as a consultant for companies or application teams that have performance issues, mostly with Hibernate. And in that case, I have a lot of arguments why you shouldn't use Hibernate. So the point is, I usually don't say, don't use Hibernate. So if you start from scratch, I would go with jOOQ without Hibernate. But if I have an existing application that already is using Hibernate, I would remove all the complex queries that they use and don't use Hibernate in that case, because the most or the thing that I really dislike is reading entities using an object mapper and mapping to DTOs to send it out on an API. This literally doesn't make sense. So it's very easy to create the objects. And the point is, if you use JPA, you can use the constructor expression, or you can use Spring Data projection. But this is limited to flat objects. So you cannot use nested object with that solution. And that's why you should use jOOQ, because with jOOQ, you can read nested objects, very performant. And that's my killer argument. Usually, if I show them my competition ranking list and show them the nested directory structure, and they are already using jOOQ in the next few minutes. So that's easy. Another thing that I wasn't talking about is jOOQ is not free. or it is free for all free databases. So if you're using Postgres, MariaDB, or any other open source database, jOOQ is free of charge. But if you're using a commercial database like Oracle or SQL Server, then jOOQ has a license fee. So you have to buy a subscription, but you get support. Why is this subscription? The point is jOOQ has a lot of code that is database dependent. So jOOQ does the heavy lifting for you, so you don't have to care about which database you're using. You can even use features with jOOQ that are not directly supported by a certain database. jOOQ will emulate this functionality for you. And that's the reason why jOOQ has some subscription fee for commercial databases. But usually this is not a point because it's not very expensive. So it's compared to the license fee for the database, it's like, it feels like a tip, not like a really fee.
Yeah, I heard the Fuji podcast with Lucas in it, where he explained like, yeah, if you have to pay like hundreds or tens of thousands of euros for the license for the database, then sending me a couple hundred is not going to damage your company that much. So that was a good one.
Exactly.
You said that you were teaching at the university these kind of things, and I'm kind of wondering, because I have like a teacher's background as well. How do the students react to jOOQ compared to JPA? Because JPA is this weird abstraction layer that it's actually objects, but it creates queries. And from my perspective, students find that really hard to grasp, while something like jOOQ is a bit closer to what they learn in like the database subjects. So what's your experience with this?
Yeah, the point is I'm teaching in different courses. I usually teach in continuing education courses. So I teach software developers that are already developing software for a few years. So, but I also teaching in bachelor studies, and there it's completely different. So these are all fresh developers. They don't know a lot about persistence, but usually in continuing education, it's also relatively easy to convince them or to show them jOOQ, because they're using JPA mainly, but I also show jOOQ for sure. But they already have a lot of questions, because they had so many problems with lazy initialization exceptions, for example, or stale object exceptions or stuff like that. And there it's very easy to show them that there's maybe a better way to do that. The point with JPA, by the way, is not really, I mean, JPA is great, or Hibernate is great. That's a really great piece of software with, I don't know how many millions lines of code are in Hibernate, and Hibernate works very well. The point is that it's a leaky abstraction. So it's very hard to abstract the SQL database. So you always have to deal with SQL anyway. But the other point is that usually people don't use it as they should use it. So they use it in a naive way, and this leads to, I don't know, the problems. It's hard to explain. So maybe they go ahead and create a class model, and then they map each relationship between all the classes with Hibernate. And that's something you should never do. That doesn't make sense. You should really follow, like if you're doing domain-driven design, you should follow the aggregate root ID and just map relationships inside an aggregate root, and with the other aggregates you should just map the IDs, not the entities. So yeah, I hope this answers your question.
Absolutely. I saw that there was another question in chat, by the way.
Yeah, that's right. Thank you, Tom.
Does jOOQ support persistent layer vis-a-vis cloud native microservices? I don't exactly know what the question is.
Venkata, do you want to explain? Venkata, are you there? Oh,
MicroStream. Yeah, MicroStream is a great. I was lucky to be at Markus Kett's talk at JCon about MicroStream recently, so that's why I know MicroStream. MicroStream is a completely different ID. MicroStream has the idea that you always work on an object model in memory. And persistent is just a side effect, or kind of a side effect. So MicroStream can serialize the data to a SQL database, to an S3 blob store, to whatever. It doesn't matter. So it doesn't embrace the persistent layer. It just sits on top. It's like you would do Java serialization to file system, more or less. So it has some advanced features for sure. So it's not that easy or that simple as I explain it, but it has a completely different ID. The ID of jOOQ or of SQL or of SQL databases is usually you really want to have the SQL database. In terms of the application is just a consumer of the SQL database, but maybe just one. And in my experience, I do software development for close to 30 years. I know a lot of applications, even my application, by the way, it's called JTAF4. That means that's the fourth generation of my pet project, but the database model was always the same. So I didn't change the database model, I changed just the application that sits on top of the database model. And if you have data-centric applications like ERP systems or any other enterprise business applications, the database structure and also the database stays usually longer than the application. And you add applications. So you create new ones or you replace existing applications. So the power of this solution is that the SQL database is like it's self-contained, means you have a meta model. So it doesn't matter if you use Java, C# or you use JavaScript or any other programming language, you can always access the database. If you're using a solution like MicroStream, you're probably bound to the API that the MicroStream provides. So you're more limited, and if you look at the idea of MicroStream, then you're probably limited to an object-oriented programming language. So if you're doing functional programming, F# or something other, then you may not use MicroStream, but you can always use a SQL database. So that's a different kind of an abstraction layer. And jOOQ just leverages SQL to Java layer. By the way, like, I don't know, 25 years ago or so, there was something called SQL J. That was embedded SQL. So you wrote SQL directly in a Java source code, and then you had a precompiler that translated the embedded SQL into Java JDBC code. That was built by IBM because IBM on the IBM mainframe computers had embedded SQL for COBOL. By the way, I was a COBOL programmer 30 years ago, and there we had that. And the idea was that this precompiler also checked the code, the SQL code. And jOOQ is kind of an advanced embedded SQL. And so you have compile time safety of the SQL statements and also of the type safety of the database objects.
Okay, cool. Yeah, thank you. Thanks a lot. So I guess if I may also ask, maybe this is a question, I don't know if it's silly or not, but does it make a difference, right? jOOQ for NoSQL, right? Does it, is there any kind of difference, right, when it operates on NoSQL database, or does it matter at all? Or just
jOOQ cannot operate on NoSQL databases. jOOQ only supports SQL databases. That's not entirely true, because there are some NoSQL databases that have a SQL interface. But the point is that usually if you use jOOQ, you most of the time really have SQL databases. So I would say most of my clients have Oracle databases traditionally. A lot of them are moving to Postgres because of license costs. And there are some MySQL databases around, a few MariaDB, and that's it. Or SQL Server. I also have SQL Server customers, by the way. But because if you have NoSQL, you maybe don't need this mapping layer. So if you look at MongoDB, you just store your objects as like, what's it, JSON, I think, is kind of a JSON format that you store there. So you don't have a mapping. So you just store a document, and that can be easily translated to an object tree. And so you don't need the mapping. So it's really for SQL databases.
Okay, cool. Thank you. Thank you. And Tom just says the FoodJ podcast. Thanks for sharing that link. Yeah, Tom's share link. And Venkata has another question. If I may ask, is there equivalent of event-driven microservices, message broker, Kafka for jOOQ?
Not as far as I know. The point is, I mean, if you have event-driven microservices, or if you do event-driven stuff, it depends a bit what you do with events. So finally, if you just use Kafka as the source of truth, then you could also, I mean, there is also Kafka SQL or KSQL. It's called, that's like, then you get an infinite stream back from Kafka, for example. But this is not supported by jOOQ. But other than that, you may also have like an event store where you store the events. And depending on what you do with the events, you could also transform it. So if you use something like CQRS, you could create a SQL database for the query part. And then you could use jOOQ to fetch the data, and messages to update, or events to update the data. So that could be also possible. By the way, jOOQ is also reactive. So if you have a reactive database, then jOOQ can use the R2DBC, that's the reactive database driver that is supported by many databases already. And then you will get back from jOOQ not a list or a result, you will get back a flux. So we will also get back kind of an infinite stream that you can consume directly with jOOQ.
Oh, nice. Nice. Okay, cool. Yep. That's right. Okay, any more questions? So with that, I think we can, it comes to the end of this meetup. Thank you everybody for having joined us today. And then thank you again to Simon. And again, we have our Discord channel if you want to continue any conversations with one another, with Simon, with anybody who wants to join our Discord server. Again, I'll share again that link here before I exit this.